All right. Final exam time. Final exam scheduled time is a week from Friday, 9 days from now, in this room at 2 p.m. So we have an early final exam. We're the first day of exam week, which is Friday, April the 30th, here, 2 to 4:30 time slots. You will need your device. You will probably benefit from bringing some scratch paper. You will have 2.5 hours. In my opinion, you will not need 2.5 hours. Most people take about an hour. But you're entitled to the 2.5 hours if you want. The exam is comprehensive, which means it covers everything from throughout the course. So if you struggled with portions of earlier exams, make sure you review those sections. And we'll have some emphasis on the post-exam 3 content, the chapter 7 content, the stuff we're going over now. Our schedule from here on out, we will cover 7.3 this Friday. We'll cover 7.4 next Monday. A week from today on Wednesday is our in-class review, and I've already sent you a link to the tutor's online review session. And then you are free. Questions about anything schedule, logistical? Yes, sir.
Are calculators allowed in the exam? Or like,
I'm going to double check. I don't think if I decide to include things from that section, I'll let you bring a calculator. If not, then you won't be allowed a calculator. I'll tell you by the in-class review session time. Yes.
When are we supposed to turn in all our homework assignments?
Yeah, the homework. Here's what we're going to do. We're still supposed to be like minimizing like back and forth paper exchanges because of COVID. I suspect that's the sort of thing that's not really necessary anymore, but I'll honor the policy for the rest of the semester. So what I'm going to do is this. On Scholar, I will open up a submission link, and I'm going to ask you to submit either Word documents or photos of certain homework assignments. And I'll also ask you to estimate, what percentage of the homework you completed. And frankly, the point of that is so for you to get credit for, frankly, all that hard work you do, because that's what is a huge time sink. I get that. So you deserve some credit. And generally, I give between 80 and 95s to students who submit the homework. So generally, that serves to bring people's grades up, unless of course they just don't submit anything through the work. In which case, a 10% zero. Well, hopefully you know math well enough to know the effects of it. Yes.
When will that drop off?
Sometime between now and the final. I mean, I'll make it due the day of the final exam. Actually, that's probably something I should do, because normally what I do is I bring in a suitcase and I ask everyone to put in their, sort of homework folder. And it turns out that 40 homework folders gets quite cumbersome. And then there's the student that I glare at, the student who did their homework in a loose leaf binder and insists on putting the whole binder in my, Imagine carrying 40 loose leaf binders. This is not a welcome. Question?
I know you said like we should take an hour, so even if we don't finish the practice, and that's still okay.
Yeah, that's still okay. I mean, look, if there was something that I asked for that you just didn't get to because you reached the hour and that was it, then just make sure that's noted that that's what happened. Now, that being said, if I told you to do something like 7.1a, and you say in an hour you did 2 problems, then that's a problem. I mean, So yeah, you would lose some credit for that. So here's secret option number 3. Wait till, make sure that you've done all of that. You can go back. I mean, I'm not going to ask for 20 homeworks. I'm going to ask for 3. So, you can always go back and do a few more that have. I mean, that's what I would do. But still, I feel good about telling you not to, for some of the assignments, there were like 60 exercises, and it just wasn't necessary for you to get to all 60. And if you didn't, that was okay. All right. Let's talk about refuting arguments. So we have given you a method for approaching the situation, for using S&I rules to demonstrate that a certain conclusion validly follows from certain premises. Today, we're going to give you the tools. We're going to talk about what it looks like to do kind of the exact opposite. So here, we're going to give you some premises and a conclusion that does not follow from the premises. So here, I'm going to ask you to do basically a disproof, a refutation that shows that this conclusion does not, in fact, follow from the premises. So here we have something very similar to the main example we used in 7.1, but we have a vital premise missing. So this is the logic for, so premise 1 is T, which stands for the only people at the manor were the butler and the maid. Premise 2 is if the only people at the manor were the butler and the maid, then either the butler or the maid did it. Premise 3 is if the maid did it, then she had a motive. But note, we have left off premise 4. We have not given you premise 4. Premise 4 was that the maid does not, in fact, have a motive. So from these 3 premises, we're going to ask you to show that the butler did it. And it turns out that you cannot show that the butler did it without missing premise 4, without the claim that the maid did not, in fact, have a motive. So here, we want to use very similar premises, omitting the vital one. And we want you to show that the conclusion does not follow from these premises, that this is not a valid argument. So how do we want you to do that? Well, we want you to use the same tools that we used in 7.1. We want you to start off by assuming the opposite of the conclusion. In Chapter 7, for any of the problems that we talk about in Chapter 7, if I ask you, what do we do first? The correct answer, no matter what kind of problem it is or how hard the problem is, the correct answer to what do you do first is always assume the opposite of the conclusion that you're supposed to prove or refute. So that's step 1. Then you look at premises 1 through 4, and you need to use S&I rules to try to do all the inferences that you can. So on step 5, you can derive from premises 1 and 2 from T, and if T then either B or M, you can infer B or M. From the combination of 4 and 5, from B or M and the claim not B, you can get M. And from the combination of M and if M then H, you can get H. And if you do that, then you're kind of stuck. You don't get a contradiction, but there's no other implications possible. So at this point, what we do is we follow up with truth assignments to try to show that, in a second way, to confirm that this argument is indeed invalid. And what you'll see is that the values that truth assignment gets you, T is true, M is true, H is true, B is false, they are going to be the same values as the simple letter statements here in the proof. So we'll have T true, M true, H true, and B false. And when you plug those values in, since T is true, you get premise 1 true. Since T is true and M is true, M makes this OR true, which makes this error statement true. Since M is true and H are both true, you get premise 3 true. And since B is false, the conclusion is false, thus demonstrating a second time that this argument is invalid. And that's what it looks like once you've plugged in the subscript values. Now, one question that someone might ask is, well, why do we even need an S&I strategy for showing that an argument is invalid? Don't we already have that with truth assignments? Yeah, kind of. But when we do the more complicated arguments, truth assignment isn't going to work very well unless we already know what values we're going to try to plug in. And we want to show you the advanced tools, the more powerful tools with the S&I rules, and how to do advanced arguments, both proofs and refutations, which are disproofs. All right, so let's look at this. So here is our step-by-step approach to either proving or refuting arguments. These strategies are actually very simple. What do you do first? Well, for any problem in chapter 7 that we go over, 7.1 through 7.4, first step is always to assume the opposite of the conclusion and block it off separately from the rest of the argument. Step 2 is always to use the S&I rules on all the assumptions to do all the possible inferences. And then every time you get a new inference, you want to check to see if that opens up more possible inferences until you've done all possible inferences. At that point, one of two things has happened. If you have found a contradiction, then you have proven that the argument is valid, and you use the contradiction to make one final inference, getting back to the to infer the opposite of the initial assumption, which is the conclusion which you were seeking to prove. And if you're trying to do a refutation, hopefully you did not get a contradiction, and then you use truth assignment to either affirm or refute the argument. All right, so here, let's do a couple on the board. Looking at 7.2a. All right. Premise 1 is A or B. From that, we are going to demonstrate that A does not follow from A or B. And we're going to use these step-by-steps that we suggested. Step 1, assume the opposite of the intended conclusion. Step 2, do S and I rules. Here, this is real easy. There's only one compound statement, A or B. It's an or. We have the opposite of one of the halves of the or, so we can do our or I rule inference. We've got A or B. We've got the opposite of A. We can infer out B from 1 and 2, the or rule. And at that point, we've done all of our inferences. And we have a value for A, false, and we have a value for B, true. Then we'll do a quick reductio ad absurdum, truth assignment, rather. We'll plug in falses for A's and truths for B's. And guess what? The or is true because of the B, making premise 1 true, and the A is false, making the conclusion false, demonstrating that the argument is invalid when A is demonstrated by A is false and B is true. Pretty easy. And if you think about this just sort of abstractly, you know, obviously from the claim either A is true or B is true, you know, the claim that A must be true doesn't follow from that, because this or will be true anytime B is true, and then A could be true or false. So if A is false, then A does not follow from either A or B. All right, well, but that's a real simple one. So let's kick it up a notch. Let's do a couple different ones to examine what this looks like as we make it more and more difficult. If A, then B. If C, then B. From that, we will prove that if A, then C does not follow. If A, then B. If C, then B. If A, then C does not follow. All right, premise 1, premise 2, conclusion to be refuted. So step 3 will be to assume the opposite of if A, then C. That is not the case of if A, then C. Then, so I've made my assumption. Then I will look to use S rules on 1, 2, or 3. We have a nice, easy S rule for negated conditional. So steps 4 and 5 will be the match of the left side of step 3 and the opposite of the right side. If on 3. Then once we've used all the S rules we can use, then we start looking to use I rules on 1 and 2, and we can use an I rule on 1 and 4, because 1 says if A, then B, and 4 says A. So we will get B from 1 and 4. Modus ponens error. So we've used 3, we've used 1. Now this is where it gets a little bit weird. We stare at number 2, and we want to do an inference with number 2. So we need a C to do a left to right inference. But we don't have C, we have not C, we have the opposite. We could also do an inference if we had the opposite of the right side, if we had a not B. But we don't have a not B, we have a B. So this, we can't do an inference with this. It is what is called broken. A statement is broken when you have either the match or opposite of one of the halves, but you can't do an inference. So in this case, this is broken and we can't use it. But look, we have a value for A, B, and C in the refutation set of inferences. We have A is true. We have B is true. We have C is false. And then when we plug that in, we can use our truth assignment test, and we get premise 1 is true, premise 2 is true, but the conclusion is false. Therefore, the argument is invalid. We have refuted the idea that this conclusion follows from these premises, and it can be illustrated on the values A is true, B is true, C is false. Yes, sir.
Are we deriving not C is false or C is false from?
That is in step 5, because when you use NIF on negated conditional, you get the match of the left and the opposite of the right. So from if A then C, it is not if A then C. You get the opposite of C, which is not C. In step 5.
Sorry.
Yes.
So just to clarify, when you have like a broken statement, as long as you have all of the places already.
Yes, that's right. You need to have a broken. So if there's a statement you can't do an inference with, as long as it's broken, you don't have to do anything. And what's important is to find values for each of the constituent single letters. Now, the difference between 7.2 and 7.4, in 7.4, you're going to get arguments where doing all the inferences doesn't give you all the constituent statement letters, and there's a special strategy you have to use when you're in that condition. But we're not there yet. But you do need these constituent letter values so that you can do this. Other questions? All right, let's get an initial indication. How are we doing? Thumbs up means we got it. Let's do another one. Let's do another one. Let's do number 3. Not both A and not B. And from that, show that it does not follow not both B and not A. All right. So first, we take the opposite of our conclusion. Then we have to look to use S and I rules, starting with S rules. We look at number 1, we can't do an S rule, there's no S rule for negated and. We look at statement 2, which is a regular and of course there is an S rule for negated and, for regular and. You can get the truth, the match of each half of the and. Then we look at statement 1 and we ask, can we do an inference with it? This is a negated and, so we need to match one of the halves of the and. But we only have the opposite of each half of the and. So we've used 2 and 1 is broken. But we do have a value for both B and A. So we're going to try B is true, A is false, and see if truth assignment gives us an invalid argument when we plug those in. And we do. 1 says it is not the case that both A is true and B is false. In fact, A is false and B is true, so that is a true statement. The conclusion says it is not the case that B is true and A is false. But B is true and A is false, so the conclusion is false. So the premise is true, the conclusion is false, as illustrated by B is true, A is false. All right, now these, so far, we've done kind of easy ones. I mean, this is like, you know, really short ones. Let's do a long one. And a long one that maybe truth assignment wouldn't have worked on. All right, so let's do sample 9. Not both A and B, either not A or C, therefore not both C and B. All right, what do we do first? We assume the opposite of the intended conclusion, C and B. What do we do next? We try to use S and I rules, starting with S rules. Can we do an S rule with 1? No. Can we do an S rule with 2? No. But we can do an S rule with 3, because it's just an AND. All right, now we've used 3. Now I'm going to look back at 1 and 2 and try to use 4 or 5 to do an inference. And I look at 1. 1 says not both A and B. So if either A is true or B is true, we can do an inference. And we have 5. So from 1 and 5, we get negated A. From 1 and 5, the not and rule. So we've used 3, we've used 1, 4, 5, and 6 are simples, one-letter statements. So we look suspiciously at statement 2. And 2 is an OR. So to do an inference with an OR, we need the opposite of one of the halves. But we don't have that. We have the match of one half, the C. We also have the match of the other half. So this one we can't use, it's broken. But we do have a value for A, B, and C. We have A is false, B and C are both true. And when we plug them into truth assignments, this says not both, and it is correct because A is false. Premise 1 is true. 2 says not A or C, and those are both the case. Therefore, premise 2 is true. But the conclusion says C and not both C and B, that they can't both be true, but C is true and B is true. Therefore, the argument is invalid. So, again, that actually wasn't that much longer. Oh, well. How are we feeling? Should we do another one? This time, I'll put it up, and you will talk me through this step by step. Maybe that's what we should do next. All right, so let's look at 5. There we go. Premise 1 is if A then B, then if C then D. Premise 2 is if B then D. Premise 3 is if A then C. Refute that if A then B follows. All right. What do we do first? A lot of arrows up here. What shall we do first?
Get the opposite of.
Good. That is in chapter 7, that is always the right answer to what do we do first. So step 1 is the opposite of if A then D. So it is not the case of if A then D. Okay, what do we do next? Yes?
From that, you can conclude that A is true and not B is true.
Good. So we're going to look to do S and I rules, starting with S rules. And you can't do you can't do an S rule with 1, 2, or 3. But on 4, you can use negated conditional to get A and to get not D. And this isn't a rule, but I always put a little tick mark next to a compound line when I use it to remind me I don't have to use it again. Okay, what do we do next? Yes.
You can use the, I think it's modus tollens on number 3 because you have A.
Okay, so 3 says if you have an A, you can get a C, and 5 says A. So for step 7, we will get a C from the combination of 3 and 5. That's the arrow rule. And going left to right is actually MP, modus ponens, but yeah, minor detail. All right, and we can put a little tick mark next to 3 because we've already used it. All right, what else can we do? Yes, sir. Good. So we can look at number 2, if B then D. Number 6 has a not D, so we can do step 8, which will give us a not B from 2 and 6, MT arrow rule. Then we look at number 1, and we can't do any inferences with number 1. It's not technically broken. If we were in section 7.4, we'll tell you what you're supposed to do here to break it. But we haven't given you a tool to try to break it. But there's simply no rules here to use. But we do have a value for A, B, C, and D. We have A true, B false, C true, and D false. And we'll plug that in everywhere, including statement 1, to make sure that pattern works. And we'll see if that gives us an invalid pattern. The left arrow, if A then B, is false because A is true and B is false. Since the left side of this arrow is false, it makes premise 1 true. Premise 2, since the left side of the arrow is false, makes the premise true. Premise 3, since both sides of the arrow are true, the arrow is true. The conclusion, the left side is true, but the right side is false, which is the one combination that makes the conclusion false. Therefore, it is invalid. All right, how are we doing? How many of you feel like you could do this if I gave this to you as a problem on the exam, and this gave you like a text box where you were expected to write it out? All right, good. That's promising. Well, do you want me to do more of these, or would you like me to go over exam 3 as quickly as we can? Do we have strong opinions on that? Nobody cares. Special option number 3. People just want to go out, want to call it a day, get to lunch early. All right. Well, let me just touch base here instead. How's everyone feeling? You have a final exam next week in 9 days. The doomsday counter is ticking. You all feeling confident? We doing good? All right. Is that a hand up? Yeah.
So, exam 4 is actually the final exam?
Yes, exam 4 is the final exam. It is a cumulative exam, which means it draws from, throughout the course. Obviously, I can't have stuff from every section of the course, but it will have stuff in the beginning, middle, and sort of post exam 3, with perhaps a little bit of an emphasis towards post exam 3.
Will the in-class review kind of go over what I touch on the exam?
Say that again?
Will the in-class review, like the day, Wednesday, when I go over what you're touching on?
Yes, I will give you samples of all exam terms. Here, let me give you a preview of one kind of problem that we're going to talk about on the final that we haven't exactly done yet. And it's not really part of chapter 7. I think it's sort of implicit in everything we've covered, but it's kind of important. I want you to be able to assemble valid arguments on your own. So let's say I gave you a bunch of premises, things like either the butler or the maid did it, the maid had a motive, that the maid didn't do it, that there were jewels in the house, that there was a 90% probability that there was rain that night. And I want to be able to give you a bunch of claims, and I want you to be able to spot claims that you can do an inference with to assemble your own valid argument. When you're told to assemble your own valid argument, first thing you need to throw out is anything statistical, because a valid argument must give you a 100% certain conclusion. But what I would hope is that you would spot from these possible premises, that you would spot that you can go, well, either the butler or the maid did it, but the maid didn't do it. Therefore, we may infer that the butler did it. And that is called building a valid argument from possible given premises. And in a certain sense, that's a harder skill than what we've been doing, because now I'm asking you to spot amongst possible premises what building blocks you need to assemble your own argument. And what this vaguely mirrors is a higher level order skill. When you do a paper, an upper level paper in any class, what you're supposed to be able to do is build your own valid or probable argument. And that's what this kind of skill leads to in later courses. So on review day, I'll give you at least one or two practice examples of that as well. All right. All right. I grant you an extra 7 minutes of happiness. Use it well. Thank you all.